Welcome to Competitional Facts. The people who are preparing SSC JE or RRB JE, this video will be very helpful. In this video, we will learn DC machines construction. Trust me, in this video, I covered the previously asked questions and important questions likely to be asked. So, don't forward or skip this video. Please spend 10 minutes. You will get a good clarity. First of all, key features of this video: constructional details with good explanation, and questions and problems on construction. Finally, assess yourself by attempting test without any cost by click on the link given in description. So, first of all, the construction of DC machine. The parts of the DC machine are yoke, pole core and pole shoe, armature core, commutator, brushes, armature winding. The first thing is yoke. Yoke is made up of cast steel for large machines and cast iron for small machines. The functions of yoke is to provide low reluctance path and to provide mechanical support for field holes. Actually, this is the main important bit. This is the practical view of yoke. Second one, pole core and pole shoe. Both pole core and pole shoe are made with cast steel. Pole core is not necessarily to made laminations, but pole shoe has to laminate since it is close to armature. Whenever the load changes on the armature, the current drawn by the armature is also changes. So alternating current is produced. Due to this alternating current, the flux produced by the current is also in alternating nature. That alternating flux cuts the pole shoe. The eddy currents are induced in the pole shoe. Those eddy currents cause heat. That's why pole shoe has to be laminated. And the functions of pole core is to accommodate field winding and behaves as magnet when it is excited. And the functions of pole shoe is gives mechanical support for field coil and reduce magnetic reluctance due to enlarged area. The pole, that means one pole covers 70% of pole pitch. That means pole pitch means the distance between two poles. So it is one of the most important formula. This is the practical view. Third thing is armature core. Armature core is made up of silicon steel laminations to reduce eddy current losses. The armature core is slotted on its outer periphery to accommodate armature winding. Open slots are only preferred, and there is a reason for the open type of slots, because to reduce sparking during commutation. I will make another video on commutation. In that this doubt will be cleared. Until, please keep this point in your mind. And the armature slots are skewed to reduce mechanical vibrations. Skewing means the slots are slightly skewed. And the next thing is commutator. Commutator is made up of hot drawn copper to reduce wear and tear. The functions of commutator is to convert AC to DC. It is also called as mechanical rectifier. For the production of torque, armature flux and field flux has to be stationary with respect to each other. The armature rotates in one direction, but the field on armature rotates in opposite direction due to commutator. To make stator and rotor fields are stationary with respect to each other. This is the most important function of commutator. Finally, brushes. The functions of brushes is used to collect armature current through commutator. Brushes are made up of copper or carbon for small machines and electrographite for large machines. Carbon brushes are mostly preferred due to self-lubrication property and high resistance. Why high resistance? There is a reason. Actually, the time constant is equals to L by R. If the brushes have high resistance, the time constant will be reduced. Due to reduced time constant, the delayed computations will be reduced. So thus the linear computation will be improved. So finally the sparking at the brushes will be reduced, and the requirement of brushes in lap winding is equals to number of poles and is equals to 2 in wave winding. Armature winding. Actually, in DC machines, the winding processes of two types: lap winding and wave winding. These are the pictorial representations of lap winding and wave winding. In lap, the number of parallel paths is equals to number of poles, but in wave winding, the number of parallel paths is equals to 2. These are the most important points thoroughly asked in competitive exams. Wave winding is used for high voltage and less current applications, and lap winding is used for low voltage and high current applications. These 2 points are also important, thoroughly asked in competitive examinations. Circulating currents are minimized by using equalizing rings. So the function of equalizer rings is to avoid unequal distribution of currents at the brushes. So this is the important formula for a number of equalizer rings necessary for a DC machines is equals to number of conductors per pair of poles. Memory based questions. The number of equalizer rings required to avoid unequal distribution of currents, lap winding and 24-turn coil. I will give it time for 15 seconds. Please answer this question. Actually, I gave the formula also. Let us see the solution. The number of equalizer rings is equals to number of conductors per pair of poles. Actually, one turn constitutes two conductors. That means one single turn is equals to two conductors. So total 48 conductors are there. 48 by 4 by 2 is equals to 24. Which coils are used for mechanical balance of armature? Dummy coils. Find the pole arc length of pole pitch of 180 degrees. For this also, I gave the formula. Pole arc by pole pitch is equals to 0.7. So finally, pole arc length is equals to 0.7 into 180 is equals to 126 degrees electrical. For more questions and attempt tests on DC machine construction, please visit link given in description below. And for more updates and get PDF of this presentation, join in our Telegram channel given link in description. Thanks you for watching Competitional Facts. Like, share and subscribe.